All right, we have example 2. Example 2 says R varies inversely as square of Q. R is equals to 4 when Q is equals to 2. Find A, the constant, B, the formula connecting R and Q, and C, R when Q is equals to 4. We have solution like this. First of all, let us interpret this. R varies inversely as square of Q. It's like this. We have R, it varies inversely as square of Q. Look at it here. It varies inversely as square of Q. Can you see that? Can you see that? Varies inversely as square of Q, like this. Q is like this. Can you see that? All right. So now, we say let the constant, let K be the constant. You see, it is important for you to define what you are referring to as what? Constant, so that as we are solving, the examiner will know what you are referring to as what? Constant. It's not all of a sudden you start putting your what? Your K without defining it. The examiner may understand, but assume that he does not understand what you are doing. Is it clear? Aha. So, and that will, it will not be of advantage to you. Instead, it will be of disadvantage. So it's better that you define it so that anywhere you see K here, you will know that it means what? Constant. All right, so I will remove this variation sign. I will put equality sign. We have like this. I have Q, then I have times what? K over 1. So that means that this, when I multiply this, I will have this. Multiplying this, I will have this. Can you see that? All right, so let me go back to the condition given to us. They said that R is equals to 4 when Q is equals to 2. That means that anywhere I see R, I will call it 4. Anywhere I see Q, I will call it what? 2. So R here, I will call it 4. I have K. Q, I will call it 2 raised to power 2. So here, this will give me this. I will have this. 2 raised to power 2 means 4. So at this point, I will do cross multiplication. K times 1 will give me K. 4 times 4 will give me what? 16. Can you see that? So that means that the constant is what? 16. So I have this constant. They say you should find the constant. It is equals to what? 16. Can you see that? All right. So let's solve number B. The B says you should find the formula connecting them. Formula connecting them simply means substitute the value of what? The constant. So we have R is equals to have K over what? Q squared. There's no much space here, so let me continue over here. So I have R is equals to K is 16, so I have 16 over Q squared. Can you see the formula connecting them? Just substitute the value of constant. That is it. All right, next one we have is question number C. All right, the question number C says find the value of R when Q is equals to 4. Remember, we are still using this. Okay, so we have R is equals to have K over this. All right, so we are looking for R. K, we have it to be 16. So Q squared means 4 raised to power 2 because Q here is what? 4. Can you see that? All right. So we have R is equals to, we have 16. 4 raised to power 2 simply means 4 times 4, which is what? 16. So this place should be what? 16. So when 16 divides itself 1, dividing this one 1. So we have that R is equals to what? 1. Can you see that? All right. So that is how it can be solved. Remember, this is Engineer Kenneth tutorial. Follow this page and share this video so that it will get to the right students that need to acquire this mathematical knowledge in order to get educated. Bye.